You before we move on. The first thing that I want to remind you of is a key component of the cell theory, that all living things are composed of at least one cell, which we've talked about really since the very beginning of the year. Now, if all living things are composed of at least one cell, that means all living things have to be able to divide to make more copies of themselves in order to ensure that three things can happen for that individual or for that organism. The first reason why we have to have cells, their cells have to be able to divide, is to be able to repair damaged cells. So cells get damaged all the time. If you get a paper cut, those are damaged cells and they have to be replaced. If you've ever had a burn, skin is constantly being sloughed off and has to be repaired, right? So we have to be able to repair. The next thing that we have to be able to do is we have to be able to grow. And we can't grow unless our cells are dividing. So think about you. Many of you, when you were born, were somewhere between 6 pounds and maybe 12 pounds at the max, right? And you guys are clearly much heavier and much larger than you were when you were born on your original birth date. The only way for you to actually get bigger, because we're not growing the individual cell size because that wouldn't be efficient. Think about our Walmarts versus our Reed's grocery stores. The only way to actually grow the organism is to make more copies of the cells. So growth is also another reason why we do cell division. The last reason why we do cellular division, and this is not true for us, but it's true for other types of organisms, is for something called asexual reproduction. And if you look at this picture here, you'll notice that we have a single-celled organism. This happens to be an amoeba. This single-celled organism is simply dividing in half and making an identical copy of itself. So all of these processes, regardless of why we're doing it, we're making identical cell copies. That's really important. We want to make the exact same thing that we started with. So asexual reproduction actually makes things called clones. So there isn't a whole lot of genetic diversity, and in fact, we don't want any genetic diversity from one generation to the next when we're talking about cellular division in this regard. All right, so now that we've talked about the cell cycle or cellular division in general, let's talk about some specifics. So the cell cycle is a time for growth and division of the cell. So you need to know what the cell cycle is actually composed of. So the cell cycle allows us to make exact copies, we talked about this before, of the starting cell. Basically, it's a fancy copy machine or Xerox machine. Now the cell cycle is divided into 3 periods. The first period is interphase, and if you look at our cell cycle here, it's this part here. It's the largest part. So interphase is the longest part of the cell cycle, and most cells spend most of their time in interphase. Mitosis is the second period of the cell cycle, which actually allows for cellular division or division of the nucleus. And then finally we have cytokinesis, which is the last period, which allows us to actually divide the cytoplasm so we can end up with 2 new identical cells. So let's go ahead and dive in and talk about each one of these periods separately. The first period that we're going to talk about is interphase. And the most important thing that you need to know about interphase is that it is the longest period. So if you had to guess what phase of the cell cycle a cell was in, it would be a pretty good guess to say interphase, because that's a majority of the time where a cell spends its time in the cell cycle. Here is where cell growth happens, metabolism, so normal chemical reactions are taking place. We're copying DNA in preparation for cellular division, and we're also copying organelles, things like mitochondria, ribosomes, the Golgi apparatus, and endoplasmic reticulum. I'm going to quickly draw a picture of what interphase would look like. This is a simple text to show you, and you guys should be copying this down on your notes as well. So in interphase, we're going to have our nucleus, we're going to have our cell, and our DNA is not going to look fancy. It's going to be loosey-goosey, just like this. So it's going to be a big pile of yarn. So this is our DNA. So it's our loose DNA. So anytime you're seeing loose DNA, you should say to yourself, well, we're definitely in interphase, because the only time that we're going to package our DNA up into our chromosome structures is when we're preparing to divide. All right, now that we've talked about interphase, let's move on to the second phase, which is mitosis. And mitosis has 4 subphases that you need to know. These 4 subphases are listed right here in order, and you do need to know them in order. The easiest way to remember the order is to think about the first letter of each one of those phases and come up with a mnemonic device or a memory clue. And what we like to say is PMAT. That's the easiest way to remember it. So we have prophase, metaphase, anaphase, and telophase. And we're going to talk about each one of those phases, and it's your job to know what's happening there and also to be able to identify what phase of mitosis a cell is actually in. All right, so let's talk about prophase first. So in prophase, some key things that are happening here are chromosomes are becoming visible. The nuclear envelope, or the outer portion of the nucleus, starts to dissolve and disappears. And we're also going to start to see spindles form. So let me show you what this actually looks like. And again, you need to be drawing the same picture in your notes. So here's my cell membrane, or the outer portion of my cell. And on my previous picture in interphase, you'll notice that I drew a clearly defined nucleus with lots of loosey-goosey DNA in the middle. That's not what we're going to do here in prophase, because we know that our nuclear envelope is starting to dissolve. And because our nuclear envelope is starting to dissolve, I'm going to draw it like this. So that's my nuclear envelope starting to dissolve. Another key characteristic is that we're actually going to see chromosomes now. So instead of our DNA being loosey-goosey, we're going to see our DNA in the shape of chromosomes, just kind of randomly floating inside of our nucleus that's starting to dissolve. We also know that we're going to start to see spindle fibers form. And so our spindles are going to be these guys that are starting to form along the outside of the cell. Our next phase is metaphase. And metaphase is a really easy phase to identify because in metaphase, we're thinking about the word M. Metaphase, the chromosomes line up in the middle or the equator. So whenever you think about metaphase, we want you to think middle. Metaphase, middle. Metaphase, middle. So here's what it's going to look like in our drawing. And again, you need to put the same drawing on your paper. So at this point, my nuclear envelope has completely disappeared, but my chromosomes are going to start to do this interesting dance, and they're going to arrange themselves along the middle or the equator of the cell. So here are 4 chromosomes. They're arranged along the middle, and we have our spindle fibers now that are starting to attach to our chromosomes, specifically to the center or the centromere of our chromosome. So again, metaphase, middle. That's the easiest thing to remember. Metaphase, middle. All of our chromosomes are lined up right down the middle of our cell. Now in anaphase, we're going to start to see something unique as well. Chromosomes are going to start to split, so we're going to break our chromosomes apart, and the 2 chromatids are going to move in opposite directions. In order to do that, our spindle fibers actually have to shorten, and when they shorten, they're going to start to pull my chromatids away from one another. So let's draw a quick picture so that we can see what it actually looks like. And again, you need to be drawing the same thing in your notes. So initially in our last picture, all of our chromosomes were lined up in the middle. But here, our chromosomes are starting to be pulled apart from one another. So we still have the same number of chromosomes, but now they've broken apart. And the reason why they've broken apart is because they're being pulled to opposite ends of the cell by our spindle fibers, which are these guys that are attached to the center or to the centromere. Now to help us remember what's actually happening here, I'm going to go ahead and draw in an arrow. These chromatids are moving in this direction, and the chromatids that were on the left-hand side are going to start to move to the left-hand side of the cell as well. Remember, the whole point of doing this is to separate our genetic material. Our last phase of mitosis is telophase. Telophase is basically just the opposite of prophase. So if you think about prophase, the nuclear envelope started to disappear. So in telophase, we're going to start to see them reappear. Chromosomes turn in or coil up and become condensed in prophase, and here they're going to start to relax and loosen back up again into loosey-goosey DNA. Instead of making our spindles, we're going to start to dissolve them, break them apart because we no longer need them, and the cytoplasm is going to start to pinch in. So let's draw a picture and see what that actually looks like. So here is my cell, Now I'm going to start to have my nuclear envelope start to reform. I'm going to have my loosey-goosey DNA again. It's no longer chromosomes because I don't need to worry about separating it. And what's going to happen is here we're going to start to see the cell pinch in a little bit and pinch in a little bit right here. Our cell membrane is going to start to pinch in because we need to start, now that we've separated the nucleus, we need to start thinking about separating the cytoplasm, which brings us to our last phase of the cell cycle, which is cytokinesis. And if we look at this term cytokinesis, cyto sounds like the word cytoplasm. So cytokinesis is basically the division of the cytoplasm after we've already separated our genetic material. So if this were actually happening in a cell, it would look something like this. So we have our nucleus here with our loosey-goosey DNA. We have another nucleus here with our loosey-goosey DNA. And the cytoplasm is pinching in here until eventually we're going to have two separate cells. And when we have these two separate cells, they're going to be genetically identical to one another. So here is a quick animation showing you what we've just talked about. So in this video, the very first thing that's going to happen is prophase. So our DNA is going to start to coil up into something called chromosomes. Our spindles are starting to form. Our nuclear envelope has disappeared. Now we're going into metaphase, and in metaphase we're going to line up our chromosomes along the equator or the middle of the cell. Anaphase is going to happen where we're splitting our chromosomes apart, so ana split, kind of like banana split. And then lastly, we have telophase, and in telophase, we're just undoing what happened in prophase. So our DNA is becoming loose again. We're going to reform our nuclear envelope. And then the last thing that's going to happen is cytokinesis, where we actually pinched off and separated our cytoplasm from one another. So at the end of this process, we end up with two identical cells from the original one that we had at the beginning when we started mitosis. All right, guys, we're at your last stop and jot. Go ahead, look at your notes, see if you can answer the questions on your day sheet. Raise your hand when you think you have the right answer so that your teacher can come over and check for correctness. Thanks so much, and make sure you study your notes. Good luck.